Hello everyone, my name is Tejasvi Nuthalapati and I work as a lead software development engineer at Amazon. And I'm super excited to be here with you today presenting my topic. So let's get started. The title of my talk is Human in the Loop MLOps. Production patterns that boost model performance by 40% while maintaining human control. Now that's definitely a mouthful, but I want to set the stage clearly. The session is not going to be abstract theory. It is about real architectures, measurable outcomes, and patterns that you can apply in your own environments. My goal is simple to show you that when we design MLOps systems in a way that balances automation with human judgment, we cannot only improve performance but also build systems that teams actually trust. So, if you've worked with machine learning in production, you know the pain of extremes. On one side, we have full automation. Everything is left to the model, and the pipelines look clean and fast. But underneath that polish, drift starts creeping in. Something like false positives show up, edge cases pile up, and before long, no one is really sure why the system is making the decisions it is making. Trust evaporates. So on the other side, we have like multiple manual bottlenecks. Every decision requires a human check. Accuracy might look good, but the system becomes slow and expensive. Humans burn out on repetitive work and throughput collapses. You heard that right. Both of these extremes fail us, and yet, too often organizations think the solution is to just double down on whichever extreme they have already chosen, more automation or like more humans. But the truth is, neither path is sustainable. So let me talk to you about the third way. This is a new concept. So instead of humans versus machines, it is humans with machines. That's the third way. Thinking of it as designing systems where AI brings scale, speed, and pattern recognition, and humans bringing judgment, context, and ethics. Each is doing what they do best at what they do. And the pipeline treats both as first class participants. Here's a story that illustrates a simple point. I was researching about a fintech company, and it was drowning in false positives in their fraud detection system. Transactions were consistently being flagged, and legitimate customers were furious. Initially, they tried tuning the models, but the improvements were a bit teeny tiny. What made the real difference was embedding structured human review into the pipeline. Analysts weren't just fixing mistakes on the side. Their decisions were logged, versioned, and directly tied to the retraining cycles. So finally, what's the result? It's the false positives dropped by 40%. It essentially means there's an uplift that just didn't come from some breakthrough algorithm. It came from re-architecting the system so that humans and machines were truly collaborative and collaborating at the same time. I'm going to talk to you about a few patterns that I've identified, and let's go one after the other. First one is the tiered autonomy. This essentially enables this collaboration that is something I call it as a tiered autonomy. So let's go back to the fraud detection example. Low value, low risk transactions where the model could have very high confidence, those could be auto approved. Medium risk cases where the model is a little bit uncertain should be routed to a human analyst, which can bring in context to the problem. And high risk cases involving large sums of money should be escalated to full human review. But with AI generated insights and supporting data attached to speed up decision making. From a technical standpoint, this can be implemented in multiple different ways. Let's start with service meshes that handle routing, CI/CD branching that responds to confidence thresholds, or even Kubernetes operators that govern which requests require intervention. But the technology is not the heart of the pattern. The heart of it is essentially designing autonomy as a spectrum instead of a binary choice. In one production deployment, the tiered autonomy reduced analyst workload by 60%. Analysts were no longer wasting time on trivial cases and their expertise. which was essentially must be concentrated towards what matters the most. And the throughput increased. And finally, the customer trust also went up. So the system as a whole became much more reliable. So I'm also going to talk about the pattern, the second pattern, which is the observable ML model, which is essentially observability in a fancy way. So if you think about it, in traditional software engineering, we would never deploy a service without logs, metrics, and traces. Yet with machine learning models, too many organizations throw models into production as opaque black boxes. Too bad. So imagine a recommendation system that suddenly starts suggesting irrelevant or outdated products. How would you see that? Just imagine. So without visibility into confidence scores, feature drift, or reasoning traces, you won't realize there's a problem until customers start complaining. By then, trust has already eroded. The solution is to bring observability patterns or the principles into ML system. That means structured decision logging. And that also means building dashboards that show confidence distributions and also drift indicators along with feature stability. That means explanations that are layered so that engineers, business stakeholders, and even end users can understand decisions at the level they need. When models become observable, two things happen. First, operators can catch drift and bias early before it becomes a crisis. And second, trust grows. Stakeholders who might otherwise resist AI adoption start to see the system as something transparent and manageable, but not as a black box. This is a huge change in perspective if you think about it. The last and the much more important one is the human in the loop pipeline. So this is the one that I'm more interested in driving the point. So right now, in many organizations, human feedback is treated as an afterthought. Meh. A human spots a mistake, files a ticket, and maybe that data makes its way back into retraining many months later. So that process is far too slow, and by the time it completes, the system might have already drifted farther apart. So instead, we should treat human feedback as first-class data. Every human correction should be logged, tied to the specific model version that um, it began, and version in the pipeline. That feedback should be automatically incorporated into retraining, so the system continuously learns. Let's look at content moderation as an example. When a moderator flags a post that model misclassified, that feedback is not just noted, it is captured, versioned, and fed right back into the pipeline. When you see this over time, the model becomes sharper, more aligned with real human judgment. In one system, I observed this loop raised the production F1 score from 0.72 to 0.84 in just a few tree training cycles, a 16% lift in measurable accuracy. That improvement didn't just come from new features or maybe new algorithms. It just came from designing the pipeline so that human judgment flowed directly into the model's learning process. And here's the few key points. As models get stronger, human input doesn't just become less valuable, it becomes more valuable. Because humans are the only ones who can guide systems through the messy, ambiguous, ethically sensitive cases that that no model will ever fully master. Just what I said. So the final one is the scalable oversight, which deals with the reality of scale. As systems grow, you cannot have humans reviewing every single decision of yours. That simply doesn't scale. But if you reduce human oversight too much, you expose yourself to risk. The answer is adaptive oversight. You guessed it right. So you stratify risk levels. You just use intelligent sampling and you design escalation paths. Take supply chain anomaly detection as an example. Instead of reviewing every alert, the team oversampled low confidence cases and routed them to humans. By doing so, they caught 90% of novel anomalies, things the model had never seen before, while cutting overall human workload in half. That's what scalable oversight looks. Human attention grows sublinearly with system growth. You still have the quality and the trust that human review provides, but without overwhelming your people. Just what I said. So, how do you measure success in human in the loop systems? You don't stop at model accuracy, you just don't stop there. You have to measure the system, humans as well as machines together. That means tracking the reduction in false positives. It also means measuring time to drift detection. It means calculating how quickly human feedback makes its way into retraining. It even means surveying operator confidence. Because a system that humans trust is one that they actually use effectively across multiple organizations. Let me not forget this. So, these patterns have consistently driven around a 40% improvement in effective performance. Again, not because the model themselves got radically better, but because the system, not just it's the system, the collaboration between humans and machines was architected more intelligently. Let's look farther ahead. The future of MLOps is not about squeezing humans out of the loop, it's just about amplifying them. Machines will continue to handle scale, speed, and repetitive pattern recognition, but humans will continue to provide oversight, creativity, and ethical grounding. When we design systems with that balance, we don't just get models that are a few percentage points more accurate. We get systems that organizations actually trust. We get pipelines that operators can debug as well as improve. And also, let's not forget, and we get Gen AI that end users feel confident depending on. So, my closing thought is this: stop thinking of humans and AI as substitutes, start thinking of them as co collaborators. This is where the real 40% uplift comes from. And that is how we build the next generation of production MLOps systems. Systems that are powerful, scalable, and trustworthy. Trustworthy. Thank you.